Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be focusing on the 10th question from the May-June 2024 Mathematics Paper 2 examination. Please note that the other questions are already uploaded, and each and every question will have its own video. And guys, it's very important for you to know how to tackle exam questions. I believe it will give you an edge whenever you write your exam. So please do share the video to your peers so that they may have the same edge as well. Né? And please do guys answer all the questions. Please. Okay, and please help us to grow the channel by just subscribing. In the diagram, COD is a diameter to the circle with center O. By just reading that first sentence, there are things I need to think about. Firstly, I'm told about the diameter. Né? COD is my diameter. I know that the diameter will always subtend an angle of 90 degrees at the circumference, such that angle CBD will be equal to 90 degrees, as well as angle CFD. They are both equal to 90 degrees. Why? Because they are subtended by a diameter. And then I've heard the phrase center. Okay, we've spoken about the diameter. The word center, there are two theorems I need to think about. Firstly is the relationship between the line drawn from the center and the chord that will be intersected by that line. All together. And then secondly, I need to think of the theorem which states that an angle at center is two times the angle at circumference. Okay, and then as we continue, the statement says EA is a tangent to the circle at F. EA is a tangent to the circle at F. Since I only have one tangent, I don't need to think about the theorem that talks about two tangents which come from the same point. You know? The only theorems I need to think about is the one which states that the angle between the tangent and the chord is equal to the angle subtended by the chord in the alternate segment. All together, such that angle F4 will be equal to angle C2. Okay, as well as the relationship between the radius and the tangent. According to 10 radius theorem, OF, which is my radius, will be perpendicular to EA, which is my tangent, according to 10 radius theorem. Okay, now let's continue reading. Diameter COD produced intersect the tangent to the circle at E, and then OB intersects the tangent to the circle at A, and then we are told that CF intersects OB at T. There's T over there, and then CB, BD, OF, and FD are drawn. First question, they want us to answer with reasons that TODF is a cyclic quad. The shape TODF is a cyclic quad. This shape over here. Okay, whenever guys I'm being asked to prove that a particular shape is a cyclic quad, there are three things I'm supposed to choose from. Né? I can either show that the opposite angles, probably angle A and B, their sum is just equal to 180. If I can show that opposite angles are supplementary, then I've shown that this particular shape is a cyclic quad. Or if I can simply show that the exterior angle is equal to the interior opposite angle, that means that particular shape, this one is a cyclic quad. Or if I can show that the angles in the same segment are the same, that means I can conclude that this is a cyclic quad. Are you together? So I need to prove that a particular shape is a cyclic quad by just showing one of the three things that it's true. Are you together? But in this case, I already angle O1, which is an exterior angle of shape TODF. That means I'm going to show that the exterior angle is equal to the interior opposite angle. Né? Okay. I already know that angle O1 is equal to 90 degrees? Because I was given that CE is perpendicular to OA. Are you together? And what else do I know? I know that angle CFD is equal to 90 degrees. This is an angle in a semicircle. This angle over here is equal to 90 degrees. So now I know that, okay, the exterior angle of this particular shape is basically equal to the interior opposite angle. I can therefore conclude that angle O1 is equal to angle CFD. Why? Because both angles are equal to 90 degrees. Okay? And therefore, I can simply say TODF is a cyclic quad. And the reason behind that, let me write it in red. The reason will simply say the exterior angle is equal to the interior opposite angle. And then you must write down those two angles. O1 is equal to angle CFD. Now I've proven that TOFD is a cyclic quad. Are you together? Okay, the next question, I'm supposed to show that angle D3 is equal to angle T1. Angle D3 is equal to angle T1. Okay, how can I show that? Remember that, guys, I've already proven that I have a cyclic quad. I've already proven that I have a cyclic quad. Let me draw it like this. Okay, and D3 is an exterior angle of my cyclic quad. D3 is an exterior angle of my cyclic quad. So what do I know? I know that angle D3 is just equal to angle T3. This is an exterior angle of my cyclic quad. My cyclic quad TODF. Are you together? But I also know that angle T1 is also equal to angle T3. These are vertically opposite angles. And therefore I can simply say that D3 is also equal to angle T1. Why am I saying that? Because both angles are equal to angle T3. Then now I've proven that angle D3 is equal to angle T1. Okay, on the next question, I'm supposed to show that triangle TFO is similar to triangle DFE. I just need to compare two triangles over here. Okay, let me write on the other side. So I'll simply say in triangle TFO and triangle DFE. Ne? Okay, let me highlight the triangles I'm comparing. Where is TFO? There is TFO, and then DFE is over there. Okay, the two triangles I'm comparing. Firstly, I know that angle D3 is equal to angle T3 because D3 is an exterior angle of a cyclic quad. Ne? D3 will be equal to angle T3. Are you together? Why? Because D3 is an exterior angle of a cyclic quad TODF. Okay, and then secondly, I know that F4 is equal to angle C2. This angle and that angle are equal. Why? Because of Tan-Cot theorem. Tan-Cot theorem, ne? But what else do I know? I know that angle C2 is basically equal to angle F2. Why am I saying that? Because OC and OF are equal because they are two radius of the circle. That means triangle COF is an isosceles triangle. Are you together? I can simply say equal sides will always subtend equal angles, and then I must specify those equal sides. Those equal sides are OC being equal to OF. OC being equal to OF, ne? Okay, and then now I can therefore conclude that, okay, angle F2 is equal to angle F4. Are you together? Angle F2 is equal to angle F4, and the reason is because both angles are equal to angle C2. Are you together? Now I've proven that two angles of these two triangles are the same. Firstly, I said D3 is equal to F3, and then F4, is equal to F2. I can therefore conclude that angle O2 will be equal to angle E, and this will just be the third angle of a triangle. And therefore I can simply conclude that triangle TFO is similar to triangle DFE. Now, and the reason behind that is just angle, angle, and angle. So now I've proven that the two triangles are similar. Okay, and then now I'm supposed to show that if B2, let me erase over there. If B2 is equal to angle E, if these two angles are equal, I'm supposed to show that DB is parallel to the tangent EA. Okay, what do I know? I know that angle B2 will be equal to angle D1. Why? Because equal sides will always subtend equal angles, and those equal sides are OB, which is a radius, being equal to OD, which is another radius. I'm focusing on this triangle over there. I have an isosceles triangle. Why? Because OB and OD are equal. They are both the radius of my circle. Are we together? Such that B2 and D1 are equal. Okay, and therefore I can simply conclude that angle D1 is also equal to angle E. Why? Because both of my angles, are equal to angle B2. Remember that I was initially given that B2 is equal to angle E. This was given to me on the statement. Are you together? It was given to me. So now I know that, okay, it simply means that angle D1 and angle E are both equal because both of them are equal to angle B2. Are you together? So since these two angles are equal, I can therefore conclude that DB is parallel to EA. Why? Because the corresponding angles are equal. The corresponding angles are equal. Are you together? And those angles are angle D1 and angle E. If the corresponding angles are equal, I can therefore conclude that these two sides are parallel to one another. So now I've shown that the two sides are parallel, and then now all I have to do is to show that DO is equal to TO multiplied by FE all over AB. Okay, let me erase over there. According to the previous proof of my similarity, I can simply conclude that F, let me use a different color. FO over FE is equal to TO over DE. This is true because triangle TFO is similar to triangle DFE. This statement is true because of those two similar triangles. Are you together? I can therefore conclude that FO is equal to TO multiplied by FE all over DE. Are you together? So I already have the numerator, which is on my right hand side, and I know that FO and OD are equal. FO and OD are equal because they are just the radiuses of my circle. Né? So FO is just equal to DO. Radii. So I can therefore conclude that DO is equal to TO multiplied by FE all over DE. The only thing that is not common now is the denominator. I have DE on the other side, but over there I have AE. I have AB. Okay, so how can I work with this? Remember that, guys, I've already proven that these two are parallel to one another. Are you together? Let me use a green color. So since those two are parallel to one another, let me write over here. This question starts there. Né? I can therefore conclude that OD all over DE is the same as OB all over AB. Are you together? According to the proportionality theorem. It's prop theorem, and the prop theorem is true because DB is parallel to EA. DB is parallel to EA. Are you together? If a line drawn parallel to one side of a triangle, that line will divide the other two sides in the same proportion, such that OD over DE will be equal to OB over AB. Okay. Over here, guys, I can simply conclude that DE is equal to AB. How? You may ask yourself, how, Sway? You know why? If ever you have 2 over X divided by 2 over Y. Remember that this statement simply says the left-hand side is equal to the right-hand side. Are you together? If the numerators are equal, it simply means that the denominators should also be equal. Are you together? Over here, I have radius divided by DE is equal to the radius divided by AB. If my numerators are both equal, it simply means that my denominators should also be equal. So I now know that DE is equal to AB. I can therefore conclude that DO, which I have over there, DO is equal to TO multiplied by FE, but I know that DE and AB are equal. I can therefore conclude that this thing is just divided by AB. Now I have proven that DO is equal to the product of TO and FE all over AB. That's how, guys, you're supposed to tackle the 10th question over there. So just stay tuned and wait for more videos. Thank you.